I'd like to welcome everyone out this evening to the Dublin Linux Developer Meetup. Our guests this evening are Jeff Epler and Melissa LeBlanc-Williams from Adafruit.
Hi, thank you, Neil. Thanks for inviting me to speak tonight. My love of Python began circa 1998 when I found that Python 1.5 was a good alternative to Perl for text processing and also a good alternative to Lisp for symbolic mathematics. While I'm no longer so naive that I think there's a single best language for everyone, Python is very nearly the best language for me. Anytime I pick up a coding project, the idea that it will be written in Python is an assumption I make until it's proven wrong. For a long time, an embedded microcontroller system was one of those places where you just couldn't use Python. Instead, I got as comfortable as I could with Arduino, which wasn't too hard because at the time I was a professional C++ programmer. That's why I was really excited to learn about MicroPython, an implementation of Python for small microcontrollers. Later, when I learned that Adafruit had a board for under $10 that could run their version called CircuitPython, I couldn't help impulse purchasing one of those boards. It was called the Trinket M0, and I started writing code for it and working within the community. Little did I know that just a few years later, I would become part of the team at Adafruit that developed CircuitPython. And that's what leads me to be here talking to you tonight. A huge fraction of Adafruit's products either can have CircuitPython loaded on them or can work in conjunction with a CircuitPython board. And don't worry, if you prefer your C++ or Arduino, almost as many other products work with that environment as well. So the kind of board I'll be talking about tonight is called Feather. This is a form factor originated by Adafruit that they use on a lot of their boards. It has a USB connection, a battery connection with charging circuit, and up to 21 I/O pins. There are a whole bunch of different feathers. This one features a TFT and a Wi-Fi capable, that's to keep it fixed on my desk, a Wi-Fi capable microcontroller chip called the ESP32S2. The imaginative name is the Adafruit ESP32S2 TFT Feather, and at adafruit.com it is $25 American. All right, that felt like a big info dump, but let me head over to my screen share and talk a little about what I'll be showing you today. All right, I hope you can see my screen share now. So what I'd like to show is how easy it is to get started on one of these boards with CircuitPython. And so, with any luck, all right, so this board is fresh from the factory, loaded with a demo that was created in the Arduino environment. And I am going to show you how to load CircuitPython on it and give you a quick view of the CircuitPython website. So, you know, the top line is the easiest way to program microcontrollers. And we have 283 different boards which are supported, including a bunch of cool ones, but we're looking for ESP32S2 with the TFT. And all of these boards come with bootloaders of one kind or another. The most convenient kind is UF2. So you just download a UF2 file to your local computer. There we go. And then I will head to my terminal because I'm a very terminal-centric person here. And you give it the secret handshake, which on this board, I'll get the down cam back. On this board is clicking the reset button twice, about a half a second apart. And that brings it into the bootloader. And you can see that it has appeared as a removable USB device. Then to install CircuitPython, you copy your UF2 file, which is the firmware, onto the boot device. And it's blinking its lights here and taking time to transfer the data. UF2 is a bootloader format invented by Microsoft that appears as a mass storage device. So it's very easy for almost any kind of standard computer to install software on the microcontroller without needing a programmer. If you used Arduino way back in the day and had a parallel port dongle adapter thing, those days are gone. It's really easy, no extra hardware. So now we've loaded CircuitPython, and at the top, there's a little identification of the version. And then it has run a program called code.py that it installed, and it says hello world, and the code is done running. So, as I was saying, the bootloader operates as a mass storage device, and so does CircuitPython. And you can use any reasonable editor or even Vim to edit your program. So we can make a simple edit to our program, write it out, and then it will reload and run our new code. And a lot of what you can do is the same as desktop Python. So we can import time, we can have a while true loop, we can do a time.sleep of 1. And a lot of the basic guides for CircuitPython would then take you through, well, how do you blink an LED? But kind of what I thought was more interesting is everybody likes to talk about the weather. The weather here was warm for a couple of days, but last night it turned rainy and cloudy. And so I thought, why not show a weather forecast fetched from the internet on our little screen? And so in advance, I've taken the liberty of preparing a program for standard desktop Python that fetches the forecast from what I think is a government website over there, the national forecast. And it has some information potentially about the forecast today, tonight, and tomorrow. And we download that, and then we loop through it. And every 5 seconds, we show kind of a different section of that. And so if you run it on your desktop computer, here's what you get. It'll show the forecast for today, tonight, and I think tomorrow morning. Oh no, cold and frosty. That doesn't sound good. Here in Nebraska, it's not quite time to put out your plants, but we do have some flowers coming up. So say that we copy that code over to our CircuitPython board. And the main program needs to be called code.py. And unfortunately, it crashes. So the question becomes, what do you need to do to adapt this code over to CircuitPython? And the answer is, well, we saw that the time library is available and works the same. But in our error message here, we can see that the request module doesn't exist. And Adafruit has prepared a compatible library called Adafruit requests. So we'll change our import to import that instead. Then next up, we need some other libraries to set up the Wi-Fi connection. There is no Linux operating system here, so we have to do everything ourselves. And there's great documentation for all these libraries on our documentation website, which I'll take you on a little tour of in a little bit. And so next we need to start connecting to Wi-Fi, which we do with the Wi-Fi radio object. And this is the SSID, and it happens to have no password just because that was easiest for the purposes of this demo. So now if I were to run this, we'd connect to Wi-Fi, but we also need to prepare the socket library and then create a compatible module or a compatible object that works similar to the standard requests library of desktop Python. And I will write that out. And, oh, I said we had Adafruit requests, but it's not installed. It is a downloadable program, which the easiest way to install those is with circup. You can install circup with Pi Pi, and we can just tell it to automatically install all of the detected modules that it needs, if I remember my command line correctly. So now it's installed the Adafruit requests library, and we are connecting to Wi-Fi. We are fetching the JSON, and we're showing it. So now we have managed to adapt a program from standard Python to CircuitPython. Now with your, this is very basic. Some ways that you might take this further would be to wrap the text better, to show an image about the weather, to use a different font that was more legible. So all kinds of directions that you can take it. And then other things that you can do with CircuitPython, we do a lot of interfacing with LEDs. For interfacing with your computer, we can behave as a serial port. We can emulate mice, keyboards, joystick, act as a MIDI controller or a source of MIDI notes. So all sorts of stuff. The sky's the limit. Connect to hundreds of sensors. So I had the good fortune to start out with a program that was using nearly compatible features between Python and your desktop computer or Raspberry Pi. But learning to write this common subset is not super difficult, and it brings huge advantages. You can work on tough logic bugs on your computer alone, not even involving the microcontroller, and then load it on the device and it'll work. You can use Python features like unit tests and all those things when you're running on your desktop computer. Then you put the resulting code back on your CircuitPython board and work out the part that turns the LED on. Or using Adafruit's Blinka, which Melissa will be showing you next, you can take CircuitPython code that does things like interact with the digital IOs and LEDs and sensors over to your Raspberry Pi or other single board Linux computer. And depending on the relevant specs, you can also take that same CircuitPython code and run it on a wide array of other boards that are compatible with CircuitPython. So in closing, I want to just mention a few more things about Adafruit. And all these links I will be adding to the text chat in just a little bit. So if you don't quite hear what I say, don't sweat it. Our US storefront, which has already been shared, is adafruit.com. And our subsite, learn.adafruit.com, collects product tutorials and project guides at the bottom of every page. And I should bring these up. I have these loaded up. So here's our main website. And then here is our page of distributors and hackerspaces. So if you don't want to endure the transatlantic shipping, we have a number of options for you within the European Union. So you can probably get more convenient shipping, more convenient currency, less customs. We don't actually have anyone in Ireland right now, but at the top of the page, we kind of outline what we're looking for in distributors. If you think you happen to fit that, we would love to hear from you. So hit that apply button if that's something that resonates with you. The best way to interact with the Adafruit community and the people who can help you with your electronics projects is our Discord chat. You can go to adafru.it/discord and join over 33,000 humans spanning all time zones and almost all continents. I haven't heard of anybody connecting from Antarctica yet. All right. And yeah, if you want to get started with CircuitPython, first check out circuitpython.org. You might already have a board that's compatible. For instance, the hugely popular Raspberry Pi Pico can run it. Didn't everyone pick up one of those $5 boards? If not, my top recommendations are any board with an ESP32S2. If you are doing a Wi-Fi project, that's our top Wi-Fi chip. And then otherwise, boards with that Raspberry Pi microcontroller, the RP2040, are a great choice for almost anything but Wi-Fi. So, and then your other option is to head over to the Learn system and find a project that piques your interest with CircuitPython. And I don't know, how about animatronic cosplay wings? One of the things working for Adafruit that just brings me joy is seeing some of these projects that people do. Yeah, so that about wraps up what I wanted to tell you about. And I will be happy to take questions in a little while, but I'm going to let Melissa do her part of the talk next. So thank you again. And I will end my screen share. And screen share. And yeah, hand it over to Melissa. Thank you very much.
Hello. So my talk is called Getting to Blinky with Blinka, and this is about how easy it is to get up and running with Blinka, which is our CircuitPython compatibility layer on boards such as Raspberry Pi. So Blinka is Adafruit CircuitPython compatibility layer for MicroPython, Raspberry Pi, and other single board computers. And Blinka is actually just a collection of modules that are installed as a library. When Blinka is installed, it allows for a high level of compatibility within Python to the CircuitPython language and allows many CircuitPython scripts to run on a Linux board such as a Raspberry Pi with little to no modification. Blinka was originally written because we are already maintaining several hundred libraries between Arduino and CircuitPython. And when the Blinka project started, it was actually written with MicroPython primarily in mind, and is eventually updated to work with Linux as well. This allows the CircuitPython libraries to be reused in both MicroPython and Linux with minimal maintenance. Blinka can be installed using pip, the Python package manager, and additional CircuitPython libraries can be installed in a similar manner. This makes it very easy to use hardware with existing libraries, and the CircuitPython libraries themselves are written as in a subset of Python, which is why Blinka works. So I'm going to go ahead and start by sharing my little terminal window here. And this is, I have connected to a fresh Raspberry Pi. I use the Raspberry Pi imager just to install it, and I have done nothing on here. So I'm going to show you how to get it from just completely new SD card. This I did put in my Wi-Fi settings and the time zone and the keyboard and all that sort of stuff using the imager itself, but otherwise this is brand new. So I'm going to just be copying and pasting in commands so it'll be faster. So I'm going to start with just doing the standards update and upgrade here to make sure we have the latest packages. And that's just going to take a minute because it's actually pretty recent. That shouldn't take too long here. So I am often setting up brand new boards on here. So a lot of times I'll go through and I have to do this. So that's actually already done now. So we're going to go ahead and install pip, which also installs Python 3 as the package manager because it does not come on the light installation. And so that just takes a minute to do there. And then we're going to go ahead and once that's installed, we're going to use pip to install a couple extra Python packages, which will help here. And these are the setup tools, which will upgrade, as well as a library that I had written called Python Shell, which allows easy use to convert a lot of the Python scripts over to, or the shell scripts over to using Python, and allows them to be a lot more maintainable. And then we have a script that I've written that will go ahead and it'll go through and install Blinka here. And I'm going to go ahead and run that. And this will enable like your I2C, your SPI, your serial port. It'll make sure all the things are up to the latest, up to date, make sure your kernel's up to date. It's been restarted if you had a kernel update. And it just kind of does a little bit of housekeeping on there. So it's a little bit nicer to install. I'm going to actually not go ahead and reboot, even though it'll ask me to at the end here. But it does a pretty good job of getting everything all up there. And if you have a Raspberry Pi that you already have set up on there and you just want to add Blinka, you can actually just do a pip3 install. So it'd be something like this. Since I've already installed it, it would go ahead and say it's already been installed. So it's not going to really do much. And so we now actually have Blinka installed. I'm going to go ahead and start Python. And I can do an import board. And I know it's working because it's not erroring. But I'm going to actually go ahead and share my full screen here. Let's see. Yes. stop sharing, and then I'm going to share the entire desktop here. Oops. Okay. And then are you able to see my desktop now? I'm assuming you can.
Yes, we can.
Oh, good. Thank you, Jeff. Okay, so that way I can show video as well on here. And so this is just my Raspberry Pi here. I'm going to go ahead and hook this up to it really quick. This is a cobbler, which allows it so that I can just easily wire up. I have a LED and a button attached to here. And I'm actually going to be taking this code right out of the guide that we have for setting up the Raspberry Pi and just pasting it right into here. So I'm going to go ahead and just paste that, and then to run it, just run it, and you can see it's blinking. It's that easy to get it going. And then I'm going to go ahead and show this one as well, which basically will light up the LED when you push the button. And so if I go ahead and I push this button, you can see it lights up when it's pushed. So it's reading an input as well as doing an output for the LED. And then if we want to do something a little bit more advanced, I have this little temperature sensor here. It's a BME 280, which is a pretty common sensor. And I'm just going to go ahead and plug it into here while it's live. I'm just going to go on to the so we can run like an I2C detect just to make sure that it's hooked up correctly. And it shows us the 77 down here. So that means it is correct. And then we can go ahead and just install the library really quick. Let's go ahead and paste that in there. And then run it. And as you can see, it's reading the temperature. It's that quick just to use like an I2C device. So there's that. And that's it for the demo. I'm going to go ahead and show a couple other projects here. So I'm going to stop sharing my screen for the moment. And so I can actually see what my camera is showing. First project that I wanted to show you was, oh, let me share my other camera here. Okay. I have this, it's a TI calculator that I basically have gutted and put in a Raspberry Pi Zero W. So it has the Wi-Fi. As you can see, it's kind of messy inside, held together with a lot of hot glue. That seems to be working. And I'm going to go ahead and I have a little switch that I mounted here. And so it's starting up. It actually is running an old version of Raspberry Pi. on here. I did this is actually the project that kind of got me started with working with Adafruit, because I could not get the screen working with the Raspberry Pi Zero, and I finally had to really dig into the Linux internals to kind of figure out the issue. I remember it ended up being something along the lines of adding a module to the etc modules file to get it to start up correctly. And it just takes a minute to start because it's on the slower, older Raspberry Pi Zero W. And as you can see, it's getting to the desktop. You can kind of move the mouse around just by touching the screen here. I did write keypad drivers on. Okay, first of all, let me try and get this a little closer here so you can see it better. But along the top here, it's not really shown well. There we go. Let me turn that around. You can kind of see the little icons there. I have this little battery icon is a custom script I wrote, which will read a DAC that I have wired up to the board and display the battery percentage. That is a Python script that I wrote. And actually the first Python script, it was kind of cobbling together a few different scripts in order to get to work. And then the other thing I have is, let's see if I can get the right angle here. Okay, see where it says like that 1, 2, 3, that is a little keyboard driver that I'd written in C that is constantly scanning all these keys here. And so I can actually, all these are acting as a keyboard, and I can even, there's modes, so I can change it with the mode here. Let's see, it was second mode. Oh yeah, that works. Oh yeah, you can see it's changing with it. There's a lot of glare here. Okay. So if I hit the second, you can see it's like changing to where it's a second, and then I can hit alpha and it changes to an alpha. That just kind of shows the little modes like it would be for the TI. I have a TI mode as well, so I could bring up like a TI calculator emulator and actually run it on Linux and then have all the keys mapped correctly. Anyway, so that is the first project that I wanted to show you. And then let me go ahead and change back to my other camera here. And the other one I have is this little LED sign. I'm gonna put it up here so you can kind of see that. And then I'm just gonna connect it with the terminal. And then I normally have it starting up the script, but this uses a Python library that I wrote just for the sign to make it really easy to script using Python. And so I can go ahead and do all sorts of graphics with it here. And so I have it just doing a little demo script here, and it just kind of keeps looping there until you stop it. And that is just running with a Raspberry Pi 3 on inside of there, and it's been working pretty well.
I will go back and fill in one more thing that I didn't cover. A lot of the boards on circuitpython.org are Adafruit products, but they aren't all. We have like over 24 other manufacturers whose boards are compatible with CircuitPython, and we invite anybody to contribute support for a board from whatever manufacturer to CircuitPython. Great, we'd love to take some questions.
There's a current supply problem for Raspberry Pis, Beagle Bones. A lot of the smaller ESP things, I don't think they have a big enough audience. They're still fairly available in China, at least. Do give you any idea when that supply might start to ease up? And
Oh,
become
I
available again?
absolutely don't. It's
Oh.
something that we talk about frequently in our internal meetings. And it's much more a matter of, what can we substitute, and what products can we get into the store? So like originally, one of the very popular lines were the Metro M4, which is a microcontroller from Microchip. And the availability on those is really poor. And so internally, we have been, spinning a new version of a board with a different microcontroller with similar specifications. And there's just a lot of that to do. And it's not only the main microcontroller. If you watch Lamore's program that she usually broadcasts on Sundays, she's got a section about sourcing and finding parts. And, it can be a diode or a transistor, just one single part that maybe sends you back to have to redesign a PCB. And it's a big drag. And, she's getting through it and she's smart at all that stuff, but it's not a lot of fun. Yes, it's the Desk of Lady Ada. And then the, what's the particular segment called? It's got that catchy jingle. Well, anyway.
Ion and
Yeah.
no, that's not the Ion.
No, that's the other one. It's Where in the
Great
World
Search.
Part I Need, the Great Search. Yes.
Yeah.
So yeah, a lot of live shows, but if you want to hear the latest on supply chain as we see it, the Desk of Lady Ada is probably the place to hear it.
All right, thank you. We'll wait and see what happens over time with everybody else.
But yeah, it's true. The Raspberry Pi Pico and the ESP microcontrollers are two that I think we're having much more luck sourcing here at Adafruit.
Yeah, it's interesting. And it strikes me, so I've not used CircuitPython before, and I think I should probably be fixing that pretty soon. But am I right in thinking that this is going to make the smaller microcontrollers, the Feathers, the ESP32 sort of family, much more useful than just the C++ world?
Well, I mean, it depends where you come from on the programming spectrum. You can do a lot more sophisticated things with Arduino, but it's a lot easier. The barrier to entry is a lot lower, we feel, with CircuitPython. So there are some projects that I would have liked to do with CircuitPython, and I just can't. And sometimes those are like updating a display very quickly because it's a little less responsive. You have a little less control over memory usage. But eventually you may learn both if you get really sophisticated. But if you're a first timer, and especially if you have Python experience of any kind, I think giving CircuitPython a chance is a really good idea.
Yeah.
Well, I can also show just a couple of the different form factors of Adafruit boards that I gathered up. So, of course, I mentioned we run on the Raspberry Pi Pico. This, I think, in the US is $5. I'm not sure what it's selling for over in Europe. It's probably similar. It's a fun little board. It has a good amount of RAM on it, good amount of built-in storage. Then this is in the form factor of the original Arduino, although Adafruit calls their version the Metro. And they've got an iteration of this board with the Microchip chips. They've got one with the ESP32S2, and they've probably got others that I don't know off the top of my head. This is an e-ink display, and it will run for a long time off of a battery. It's just showing the time as the Romans would have reckoned it. So it's the 7th hour of the day here. And so the e-ink display is maintained even when the board is off. And again, the microcontroller is the ESP32S2. So it's getting the time from the internet, running some calculations about what is the orientation of the Earth and where am I, like where is its programmed location. And then it figures out the Roman hour. And this will run for about 6 months on a battery charge, which is really cool to do with just some Python code. This one in a 3D printed case is called the Circuit Playground Bluefruit. It's the Bluetooth version of another board that we like to sell a lot into education called the Circuit Playground Express. So it's got a bunch of touch pads for touching. It's got a ring of RGB LEDs, and some sensors like accelerometer. So you can, sense what you're doing. There are a ton of beginner projects with this, and it kind of packages together everything you need to, a good variety of things: LED, touch, buttons, switches, sensors. And then 2 more. We have a ruler. I don't know why, but inches and millimeters for touchpads, and a low end microcontroller. So you can't fit a lot of code on this, but I use one to control my media station. I use one to control my microphone mute, because no sound when you touch the touchpads. So it's really great for that. Oh, did I say 2 more? 1 more. I have 2 more. So this is called the Trellis, and it's got these rubber dome switches, about 32 of them. They each have an RGB LED behind. It is a great one if you want to do some MIDI. You can use this as a little keyboard. You can press all the keys at once, and then you can use light and color to show what each one is. And it's got a headphone jack, so you can actually produce some sound from the device itself and listen to it on a speaker or your headphones or whatever. And then last one, if you like keyboard shortcuts, this one's called MacroPad. It's got a display, it's got a rotary encoder, and it's got 12 standard key switches that I've printed my own keycaps for. And again, it's got RGB LEDs under each key, so you can use that to remind yourself of the function and also show it on the display. And each of these products, we've got guides, we've got tutorials, we've got projects to get you started with something that you are interested in. So yeah, if you do one thing today, it's head to learn.adafruit.com and find a project that you feel like you want to do, and then pick up the parts, hopefully from a distributor somewhere in Europe. Yeah, so any more questions?
Actually
I kind of did a dump again, brain dump.
There's actually a couple other form factors, the Itsy Bitsy and the Cutie Pie ones.
That's true. Yeah, I don't have those here in front of me. And another
I can
recent,
go grab one really quick.
yeah, sure.
Just a second.
Another recent kind of emulating another form factor. Adafruit doesn't originate all these, but when we see good ideas, we like to grab them and iterate on them. So if I can just get this packaging open. This one is called, it's like getting into a package of snack. This one is called the KB2040, and it is made to go inside of keyboards. So that keyboard that you heard me clacking on earlier is something that I designed and 3D printed and put CircuitPython inside of, and I love it and I use it every day. So a lot of joy that comes out of some of these projects that I've done.
I couldn't find the Cutie Pie, but I do have the Itsy Bitsy here. It's just like about the size of a Arduino Nano, at least in terms of the pen spacing. It's a little bit shorter too.
Yeah, I think, is the KB2040 in the form factor of the Nano? Well, they're similar. There are a lot of keyboards.
They're very similar. They're not
a spot this size for a microcontroller in their design, like DIY keyboards.
Mm-hmm.
All right. Well, Melissa, any last words?
That's it.